Okay, so let's do a couple more quadratic graphing of quadratic profit functions. Let's start off with an inverse demand function, P of Q equals 48 minus 3Q. And let's say we have a cost function, C of Q equals 6Q plus 120. Okay, so what does this profit function look like, and how can we find the Q at which maximum profit occurs, and what is the profit at the profit maximizing quantity? So we're going to create a revenue function, R of Q equals 48Q minus 3Q squared. Of course my costs are this, so my profit function pi of Q equals 48Q minus 3Q squared minus 6Q minus 120. Combining and simplifying, we get negative 3Q squared plus 42Q minus 120. Now we're going to take the first derivative of that profit function, and we get negative 6Q plus 42. And of course the second derivative is going to be negative 6, so we know it's concave down, so we know we're going to have a profit maximizing Q. We graph pi of Q on a pi Q axis. We know that at negative 120, quantity is 0. So we know the function's going to start there. What is our profit maximizing Q? We're going to set the first derivative equal to 0. This means that Q star equals 7. And at 7, what is our level of profit? At pi of 7, that equals negative 3 times 7 squared plus 42 times 7 minus 120. That's going to equal, breaking out my trusty calculator, that is going to equal negative 3 times 7 squared plus 42 times 7 minus 120 equals 27. So that's my profit maximizing Q, and that's the profit at that Q. Okay, now where are my break-even points? That's going to be this point here and this point here. How do we find those? Plug the profit function into the quadratic formula. So this means that Q is going to equal negative B, which is 42 plus or minus the square root of 42 squared minus 4 times negative 3 times negative 120, all divided by negative 6. Okay, and what are these going to come out to be? These, if I'm not mistaken, should come out to be 4 and 10. Okay, but do this on your own. Go ahead and solve this on your own. But this is what our profit function looks like. Let's do one more. Let's assume we have a revenue function, which is, move this up, let's see, which is 750Q minus 5Q squared. What does this come from, by the way? It's going to come from an inverse demand function of the form, what would that form be? 750 minus 5Q q, right? Because all we do to get from here to here is multiply this by q, then we get that. So I know that's what my inverse demand function looks like. That said, let's assume we have a cost function equal to 100q plus 20,000. Okay? Big numbers and all, but it doesn't matter. It's all the same. We use a calculator to deal with the big numbers. The methodology is exactly the same, however. So we're going to put together a profit function, which would be 750q minus 5q squared, okay, minus cost, which is 100q minus 20,000. Okay. Now we're going to combine and simplify. That means my profit function looks like negative 5q squared plus 650q minus 20,000. We're going to take the first derivative of the profit function. That equals negative 10q plus 650. And of course the second derivative will be equal to negative 10, saying that the profit function is concave down, so we should have a maximum profit level. Let's go ahead and build our graph, put our graph together, pi on q. Setting this equal to 0, we're going to get q star equals 65. So at a q equal to 65, I know my profits are maximized. What is my maximum level of profit at 65 units? Well, that's going to be solved by calculating pi of q, or in this case, pi of 65. That equals negative 5 times 65 squared plus 650 times 65 minus 20,000. Calculating that, we get negative 5 times 65 squared plus 650 times 65 minus 20,000. That equals 1125. Okay, so at my profit maximizing Q, my profit is 1125. I've got fixed costs of 20,000, so when Q is 0, my profit is negative 20,000. So my profit function comes up like this, maximizes at 65 units, and comes back down. What are my break-even points? Again, they're going to be here and here, and they will be calculated by running the quadratic formula, or running this function through the quadratic formula. Once we do that, you're going to find that this intercept is 50 and this break-even point is 80. Okay, so there's not much to it. It's just like graphing. Graphing quadratic profit functions is just like graphing quadratic general functions. Okay, when it gets more complicated is when we move into graphing cubic functions, which is what we're going to do.